Hello everyone and welcome to my video on benzyne intermediate, which is also called SnEA substitution or Cine substitution. To understand this, we need to understand some basic concepts. Aryl halides has a benzene ring attached to a halide group by a single bond. Actually, aryl halides should undergo electrophilic substitution reaction as seen in alkyl halides. But it is observed that aryl halides are less reactive to nucleophilic substitution reactions. Why is it so? This can be explained considering four factors. 1. On the basis of SN2 mechanism, 2. On the basis of SN1 mechanism, 3 and 4 factors are bond multiplicity and length of carbon halide bond. All these aspects are discussed in details in my video Resonance Part 8. So now the next question is, how can you make the aryl halides more reactive? We can make the aryl halides reactive by exposing it to the drastic reaction condition, that is high temperature and pressure. Secondly, we can introduce an electron withdrawing group at ortho or para position of the aromatic ring, and that increases the reactivity of the aryl halide. Another way we can increase the reactivity of aryl halide is by treating it with a strong base. Here are some examples. Look at this reaction. Chlorobenzene undergo nucleophilic substitution reaction with aqueous NaOH only at temperature greater than 300 degrees centigrade and under pressure. But many sensitive substrates may not sustain at this high temperature and pressure. So, the other option is introduction of an electron withdrawing group at ortho and para position with respect to the halide group. This will increase the stability of the carbanion intermediate and the reaction will go faster. In the third option, we can increase the reactivity of the aryl halide by carrying out the substitution reaction in the presence of strong base like sodamide, phenyl lithium, etc. Let's take the example of chlorobenzene. When chlorobenzene is treated with sodamide or potassiumide, there will be the formation of benzyne intermediate. This is the benzyne intermediate, which will undergo substitution, nucleophilic substitution to produce aniline. The net result is the Cl group is substituted with the NH2 group. But what are benzyne intermediate? Benzyne intermediate has one additional bond, you can see here, or one additional bond between the two carbon atoms. One carbon having the hydrogen and the other carbon holding the Cl group in the starting material. This additional bond is formed by lateral overlap of the p orbitals formed by the elimination of HCl. The new bond, the electrons in the forming the new bond lies along the side of the ring and has little interaction with the pi electron clouds of the benzene ring. Therefore, the additional bond is weak and hence benzyne intermediates are very reactive. Let's have a look at the reaction mechanism, how this benzyne intermediate is formed. The reaction proceeds through two steps. The first step is elimination, which involves two steps. The first step is abstraction of the proton ortho to the Cl group by the amide ion to form ammonia and carbanion. The carbanion then loses the halide ion to form the benzyne intermediate. Okay. The second step of benzyne intermediate is addition, which also involves two steps. The first step is addition of the amide ion to the benzyne intermediate to form a carbanion. And the second step is the carbanion abstracts the proton from ammonia to form the product. And it is because of this the reaction is called nucleophilic substitution, elimination, addition, because it is a nucleophilic substitution reaction involving two steps, elimination followed by addition. Therefore, this mechanism is called SnEA mechanism. SN stands for substitution nucleophilic. E and A stands for elimination followed by addition mechanism. But why is it called Cine substitution? In chemistry dictionary, Cine substitution is the substitution reaction mostly in aromatic compounds where the entering group takes up a position adjacent to the leaving group. Remember, in regular nucleophilic substitution reaction, the nucleophile occupies the position which was occupied by the leaving group. But here in Cine substitution, the nucleophile enters the position adjacent to the leaving group. Benzyne intermediate is also called Cine substitution because in this mechanism the entering group takes up a position adjacent to the leaving group. Let's look at the isotopic labeling study. This is an experiment in which the chlorobenzene is labeled at this carbon atom. You can see it is labeled, it is marked as star, so the labeling is at this carbon atom. Treatment with sodamide gave a benzyne intermediate. And now there is an equal probability of attack by the nucleophile either on this carbon or on this carbon. So when the nucleophile attacks at this position, we get a carbanion like this. And when the nucleophile attacks this position, we get a carbanion like this. But actually it is observed that we do not get 50-50 amount of product. The isotopic, the Cine substitution product is obtained in 53%, whereas the regular substitution product is obtained in 47%. It is because of this the benzyne intermediate mechanism is also called Cine Substitution. That's all for today, and in the next lecture we will be looking at some examples, some applications of these reactions in organic synthesis. If you like my video, please subscribe, like, share and comment.